Okay, so in this chapter 3C, we are working with polygons. Specifically, we're talking about regular polygons. So you'll learn about the angle properties of these so-called regular polygons, reflection and rotational symmetry of regular polygons, and how we find interior angles, the inside angles of the regular polygons. So you're probably wondering at this point, what is a regular polygon as opposed to what is an irregular polygon? Here we go. Regular polygons are shapes with 3 or more straight sides. And how you know it's a regular polygon is because of these special traits. All the sides are equal, and so are all the angles. So for example, can you think of a triangle that has all the same lengths of sides and all the same lengths of angles, or same size of angles? If you guessed equilateral, then you're right. An equilateral triangle has all the same length of sides and all the same size of angles. And just a FYI, the number of sides that the shape has is equal to the number of lines of reflection symmetry and rotational symmetry. So this triangle right here, just by looking at this equilateral triangle, we already know it's got 3 lines of reflection symmetry, and I could prove it, 1, 2, and 3. And an order of 3 for rotational symmetry, because if you keep turning it, it's going to look like itself 3 times. Now, can you think of a 4-sided shape, all equal sides, all equal angles? If you guessed a square, good job. And of course, I just talked about these 2 shapes. So skill number 2, reflection and rotational symmetry of regular polygons. Draw the line of reflection symmetry and give the order of rotational symmetry. So pause the video and do this at this time. So a regular polygon that has 3 sides is called an equilateral triangle. And a quadrilateral that is considered a regular polygon is called a square. So now we have to find the lines of reflection symmetry. So split down the middle here, here, and here. Therefore, it has a reflection, 3 lines of reflection symmetry. And the order, again, it has a order of 3 for rotation symmetry. Now with the square, 1, 2, 3, 4. So you have 4 for reflection symmetry. And again, you have 4 for rotation symmetry, as we proved in the previous lesson. Now the last skill is finding interior angles of regular polygons. So remember, in a regular polygon, all the angles on the edges, the interior, are equal. So keep that in mind. Now, in this exercise, it says to calculate the angles of A, B, C, D in the regular pentagon. So this is a regular pentagon, meaning all these outside edges right here, these corners, they actually are the same angle. But we have to make sure that you're searching for A, B, C, and D specifically. And once you know that, you should be able to figure out one of those interior angles. And there's a few hints in here. So I want you to go ahead and pause the video, take in consideration of the hints that you're given to find A, B, C, and then of course finally angle D, and then do B, which is the sum, meaning the total of all the interior angles. Pause. So if you look at one of these triangles in here, you can clearly see that this is an isosceles triangle. And what do we remember about isosceles triangles? That if we trace a line straight down the two sides where they're equal, we'll eventually come to the corners that are the same length, same measure. So we know that angle B and angle C have to be the same. Now, you're thinking, well, how do we even figure that out? We don't even know what A is. What's a full rotation? 360 degrees. And how many triangles are there? 1, 2, 3, 4, 5. So first we have to do step 1, 360 degrees divided by 5, so we can figure out at least what A is. And if we do that math, we know that A equals 72. That's step 1. Now we need to find B and C, right? So here's what's great. We know that this is an isosceles triangle. We basically, our plan of attack, a triangle is equal to 180 degrees. Let's take 72 away, see what's left over. Once we know that, divide it by 2 so we can get B and C. So step 2, 180 degrees minus 72 should give you 108. Then, to find B and C, since we know they're the same because it's an isosceles triangle, 108 divided by 2 is going to give you 54 degrees. So we know that B equals 54 and C equals 54. Okay, great. We figured out A, B, C. Now, to find D, let's keep this in mind that we know that these are all equal triangles. So we know that this part is the same as B, this part is the same as C. So therefore, this whole thing is B and C added together. So D is equal to whatever B plus C is. So 54 plus 54, oh geez, that's 108. So D is 108 degrees. So A, B, C, and D. But we're not done yet. We need to find the sum of the interior angles of this regular pentagon. So what do you think you do? If you have an idea and you haven't done it yet, go ahead and pause the video. If you've already done it, continue watching. So finally, we have 1 angle, 2 angles, 3 angles, 4 angles, 5 angles. Each of them is equal to 108. So we simply have to take 108 times 5. And when you do that, you should have a total of 540 degrees. So a pentagon, a regular pentagon, or even just any pentagon, adds up to 540 degrees. And here's a fun fact. Here's a pentagon for you. I'm going to try to see how many triangles can fit into there, starting from this vertex. 1, 2, and 3. Remember how many degrees? How many degrees is one triangle? 180, 180, 180. Well, what's 180 times 3? 540. Well, isn't that interesting? A pentagon is 540 degrees, and we figured out if we dissected that shape into triangles, that we could also figure out how many degrees it is. Apparently it's 540 degrees. So you can actually use the same trick right here that I just showed you for any shape. So if we had a hexagon and we had six sides, okay, that's not very well drawn. 1, 2, 3, 4, 5, 6. Pick a corner. Make sure you draw all your lines from there to each corner. 1, 2, 3. There's 4 triangles in this. So we know each triangle is 180 degrees, so 4 times 180. We will find out that a pentagon is equal to a total of 720 degrees. So that's just a little fun fact for you. So if I ever asked you to find me the total number of degrees of interior angles on a octagon, you should be able to figure that out. Or a shape that has 102 sides. And that's it.